Bonjour, je me présente moi-même. Moi, c'est Bhavna Anthony, professeur en biologie. L'examen est tout prêt. Toutes mes élèves de haut et level à l'apprendre.mu prépare une série de past papers sessions qui peut faire en live sur Facebook. Je propose de rejoindre, faire vite, pas tarder, enregistrer sur alapprendre.mu. À bientôt!
Hello everyone, welcome to alapprendre.mu. My name is Sanjeevi Cuneapen. I will be your mathematics coach on alapprendre.mu, and today we are here to tackle a past paper question, as you know. And the aim of this past paper question, well, several past paper questions. So the aim of the past paper is to reinforce your conceptual understanding of mathematics, improve problem solving skills, and of course also improve or enhance your examination skills and techniques. So all of these are very important for you to be ready for the exams, for the additional exams, paper 1 and paper 2. So without losing too much time, we will now proceed to the paper that will be involved. So the paper, as I said, is May-June 2022. It's paper 1, and the syllabus code is 4037, paper 12. Now, just a reminder that the paper is 2 hours, roughly 120 minutes, well, exactly 120 minutes, and it's worth 80 marks. You should also read the instructions on the first page of the paper, which are very important. And one of the instructions, main instruction, which I like to reinforce is that non-exact numerical answers, they are given to 3 significant figures, angles in degrees, 1 decimal place, and angles in radians, 3 significant figures, and the rest is 3 SF or unless specified in the question. So let us now proceed to tackle question 1 for your understanding. Now, question 1 deals with trigonometric, especially trigonometric graphs. So if you look at the question, it says the diagram shows the graph of y is equal to ax plus b, a sine bx plus c, where a, b, and c are integers, and then you have the domain which lies between 180 and minus 180 inclusive. You're asked to find the values of a, b, and c. Just a reminder that for the trigonometric equations or functions y is equal to a sine bx plus c, a is the amplitude, as you can see on the graph, a is the amplitude, b is related to the period, and c is the axis. So if you see the value of a from the diagram, you will observe that the amplitude a is, so the amplitude is related to the maximum displacement from the equilibrium or the axis. You can first start by spotting the axis. The axis is y is equal to minus 5. So technically c is equal to minus 5. That's the axis. The amplitude is, the axis is y is equal to minus 3. Just looking at the diagram. The amplitude is y is equal to 5. Now, the period is the one which corresponds to one cycle. So the angle which corresponds to one cycle is the period. So period is equal to, from the graph, 90 degrees. Now, remember that the period is also equal to 360 degrees divided by b. So if I want to find the value of b, it would be 360 degrees divided by the period, which is 90 degrees. So b is equal to 4. So we got c is equal to minus 3. A is equal to 5, which is the maximum distance of the peak from the equilibrium position, and b is equal to 4. Just a recap, y is equal to a sine bx plus c. A is amplitude, b is related to the number of cycles within that period, and c is the axis of the sine curve. It can also be a cosine curve. I hope you've understood the problem. This is a rather simple question where you just need to look at the graph and generate the values in the question. Let us now proceed to the second question. In the meantime, I will just erase the solution and we will now proceed to the second question. The second question deals with trigonometry again. You have given that x is equal to sec squared of theta. So x is sec squared of theta. And then you have y plus 2, which is equal to cot squared of theta. Right? So if y is equal to cot squared of theta minus 2, just erase that a little bit, cos squared of theta minus 2. So y is equal to, the cot squared is 1 over tan squared theta minus 2. Now, from x is equal to sec squared of theta, we know the trigonometric identity, which is on the first page, or the second page of your paper. Sec squared theta is 1 plus tan squared theta, which is equal to x. Now, we need to replace the tan squared theta in the second expression for y by using the first one for x. So tan squared of theta is equal to x minus 1. So y is equal to 1 divided by tan squared of theta, which is here, x minus 1 minus 2. Now recall that when we have 2, basically we have 2 to the 1. So the LCM would be x minus 1. So y is equal to 1 minus 2 bracket x minus 1. Just a simple simplification, you will have y is equal to 1 minus 2 times x minus 1 divided by x minus 1. So the LCM would be x minus 1. Minus times minus would be positive. 1 plus 2 is 3. And I'm left with y is equal to 3 minus 2x divided by x minus 1. That's the final answer which we are looking for. So the question tells you to find y in terms of x. So y is given in terms of x, which is 3 minus 2x divided by x minus 1. I hope you've understood the problem. The first two questions, they are basically related to trigonometry. Okay, where we've made use of the identity x is equal to 1 plus tan squared theta. We've made tan squared theta the subject of formula, which is x minus 1. And then we have replaced it in the equation for y. Let us now proceed to the third question. The third question is related to linear law. The variables x and y are such that log of 2y to base 1 is plotted against x squared. A straight line graph passing through the points 1, 1 and 2, 5 is obtained. Find y in terms of x. So technically speaking, when we deal with linear law, you have, let's say the general equation of a straight line is y is equal to big X mx plus c. M is the gradient and y is, so I repeat, we'll solve the equation now. Y is equal to mx plus c, so m is the gradient and c is the y-intercept. Now in this question, you have log of 2y plus 1, which is on the vertical axis. So I can rewrite the equation as log of 2y plus 1 is equal to m. The x is represented by x squared as specified in the question, and then plus c, which is the y-intercept. So basically the y represents log of 2y plus 1, the x represents x squared, and c is the y-intercept. Now the nice thing about that is you can find the gradient, which is very simple, because the line is passing through 2 points. Let's call it A, 1, 1, which is given in the question, B, which is 2, 5. So remember, we are solving part 1. Now, we have 2 points, we can surely find the gradient of the line. So gradient, which is m, is 5 minus 1 divided by 2 minus 1. So gradient is equal to 4. So we got the gradient. So I can rewrite my equation as Lg 2y plus 1 is equal to gradient, which is 4 x squared, plus the y-intercept, which is c. Now, to find the y-intercept, we need to use a point which is given. If I look at the point, you see that 1, 1 is the most simplest one. So when I say the point A is 1, 1, it means that the x-coordinate on this graph, which is x squared, is 1, and the y-coordinate on the same graph is basically Lg of 2y plus 1. So if I substitute, I'll write the point here so that you can see it straight away. If I substitute the log of 2y plus 1 by 1, right, and I have the x squared by 1 plus c, then what happens? You have c, which is equal to 1 minus 4, which is minus 3. So we got the value of the gradient, which is 4. We got the y-intercept, which is c. We'll continue with the calculation. Now, as I said, the equation which we are dealing now is this one. So let's replace all the values. So log of 2y plus 1 is equal to m, which is the gradient, 4x squared, plus c, which is minus 3. Okay? Now, don't forget that Lg is log of 2y plus 1 to base 10. And that's equal to 4x squared minus 3. So when I change it to index form, I have 2y plus 1, which is equal to 10 to the power of 4x squared minus 3. So 2y plus 1 is equal to 10 to the power of 4x squared minus 3. 2y is equal to 10 4x squared minus 3. The 1 goes on the right hand side, I have the minus 1 there. And if I make y the subject of formula as requested in the question, is y is equal to half, big bracket so that you can see it carefully, 10 4x squared minus 3 subtract 1. So this is my final answer for the first part. So y is equal to half. Okay, I'll move to this side so that you can see it. Y is equal to half 10 to the power of 4x squared minus 3 minus 1, and that's the answer for the first part. So I'll give you a few minutes to take a look at the problem. The first part is quite simple. It just deals with the concept of straight line and finding the gradient and the y-intercept for linear law. Any question, please post live online on Facebook and we'll try to answer it during the pause. We will now proceed to the second question and I will erase the solution. So part B. So question 2, part B. So we are solving the question live, so it takes time to erase everything neatly so that you can see the working clearly. Now, the second part of the problem is find the value of y when x is equal to root of 3. Now, for the first part, you've already made y the subject of formula. Fine, no problem. So let's copy it. So part A, we've said that y is equal to half 10 to the power of 4x squared minus 3, and then we have minus 1. That's the equation which we got in part 1. Now, for part B, you are asked to find the value of y when x is equal to root of 3 over 2. X is equal to root of 3 over 2 here. So we need to find the value of y. Let me write it properly so that you can see it on the screen. So root of 3 over 2. So we just need to substitute the x here. So y is equal to half bracket 10 4x squared, which means, let's do the calculation aside. Root of 3 over 2 to the squared would be root of 3 to the squared, which is 3, 2 to the squared, which is 4. So the x squared can be replaced by 3 over 4, right? Minus 3. Okay, and then we need to subtract the 1 here. So y is equal to half. Okay, now simple calculation. The 4 cross out. 3 minus 3 is 0. We are left with 10 to the power of 0 minus 1. Now, simple IGCSE maths, not even IGCSE, I would say grade 9 maths. 10 to the power of 10 to the power of 0 is 1. So y is equal to half. 1 minus 1, so y is 0 for the first part of the problem. So when x is equal to root of 3 over 2, y is equal to 0. Again, it is just substituting once you get the original answer, expression or equation from part 1. Okay? Now, that's just substituting in the equation which we derived in the first part. We will proceed to the part C of the same question. Find the value of x when y is equal to 2. So in that case, I will erase that because I'll try to write it here so that you can see it. So part C means find the value of x when y is equal to 2. So let's start the problem here. Y is equal to 2 in this case. So basically, we use the same equation. Y is equal to, let's say, half 10 to the power of 4x squared minus 3 minus 1, and this has to be equal to 2. So the y is 2. I can just write it here for simplicity. That's just straightforward. Now, if the half is, you have half here. If I send it on the right hand side, we will have 10 4x squared minus 3 minus 1, 2 times 2, which is equal to 4. So 10 to the power of 4x squared minus 3, the minus 1 goes on the right hand side, you will have 5. At this stage, you need to be careful. If you look at the base, they are not the same. So if they are not the same, can we make it the same? No. 10 and 5, it's difficult for us to make it to the same base. What we shall do, we shall apply log to base 10, which is the most simple. So if I apply LG, 10 to the power of 4x squared minus 3, you would have LG 5 on the right hand side. Remember the laws of logarithm, the power, which is the whole thing here, can be set on the right hand side for simplicity. So we have 4x squared minus 3 LG10, which is equal to LG5. LG10 is what? I'll write it here. LG10 is 1, because LG10 is log of 10 to base 10, which is 1. Don't forget this simple, I'll just move a bit aside, don't forget this simple relationship. Log of 10 to base 10 is 1. So here we have 4x squared minus 3, which is equal to LG5. We need to solve for the value of x, so we have to make x the subject of formula. So x, 4x squared, is equal to 3 plus LG5. The 3 goes on the right hand side. X would be equal to, remember this is x squared, so when you send the 4 there, you would have 3 plus LG5 divided by 4. But when you take the square root, plus or minus, you would have square root of the whole thing. So plus or minus square root of 3 plus LG5 divided by 4. If you give me a few minutes, I'm going to do the calculation together with you, because as I said, it's a live session. Use your scientific calculator. I'm using my mobile to do the calculation. But remember that in your exam, mobile is not allowed. You have to use your scientific calculator as prescribed by the syllabus, the required model. So 3 plus LG5 divided by 4, and square root of that would give me, so x is equal to plus or minus 0.962 to 3 significant figures. So x is equal to plus or minus 0.962 to 3 significant figures, and that's the answer. So remember why I'm giving it to 3 significant figures. If you go back to the first page on the list of instructions for your paper, non-exact numerical answers should be given to 3 significant figures, angle in degrees to 1 decimal place, unless a different level of accuracy is specified in the question. I'm quoting the statement on the first page, so if you don't write your answer correct to 3 significant figures, when it is non-exact, you lose the accuracy mark, which is technically you lose the answer mark. You can always check the mark scheme to see how the marks are allocated. Maybe in the future session we can discuss a bit more about that. So just take a look at the solution for a few minutes, and then we are going to take a pause for 5 minutes where you can go through the questions and send your queries for me to reply. Thank you very much. Hope you've enjoyed with solving the problem with me. Till now, as I said, it is live, so we feel the same stress which you have in the exam, and that's the point of solving questions live together with you. See you in 5 minutes. Stay tuned.
Bonjour, me présente moi-même. Moi, c'est Bhavna Anthony, professeur en biologie. L'examen est tout prêt. Mes élèves de haut et A-level à l'apprendre.mu prépare une série de past paper sessions qui peut faire en live sur Facebook. Me propose de rejoindre, faire vite, pas tarder, enregistrer sur alapprendre.mu. À bientôt!
Welcome back, my friends, students, for the continuous live. Remember, we are solving past papers questions for additional maths paper 1. Stay with me, stay with us and enjoy. Now, question number 4. Let's go to question number 4 and see how do we deal with question number 4. For question number 4, you have find the unit vector in the same direction as minus 15 and 8. Now, unit vectors. When we talk about unit vectors in maths, a unit vector is one which has magnitude 1. So the modulus basically of the unit vector is 1. The magnitude is 1. The length is 1. Now, recall that for the formula of unit vector, so A, let's say the vector A, we put a cap on it when we are talking about unit vectors. It's equal to the vector divided by the modulus of the vector, right? As simple as that. So unit vector is equal to a vector A divided by the modulus of A. We have a vector which is minus 15 and 8. We want to find a unit vector in the direction as minus 15 and 8. What do we do? The first step is to calculate the magnitude because it's straightforward. So I'll write that's question number 4a. So the magnitude would be modulus of A. The vector is minus 15 and 8. So the magnitude of A would be basically square root of minus 15 to the squared plus 8 to the squared, right? So modulus of A would be basically 15 to the squared is 25, 8 to the squared, which is 64, so that gives us square root of 289, which is 17 units. So modulus of A is 17 units, the magnitude is 17 units. Now don't forget, we need to find the unit vector. I'm going to use that formula. So the unit vector would be A, let's call it A unit vector, in that form denoted by the cap. It's the vector, which is minus 15, 8. Let me remove the bar there, so it's not division, it's just a column vector, minus 15 and 8, divided by the modulus of the vector, which is 17. This can be nicely expressed as 1 over 17 minus 15 and 8, so that's the answer for the unit vector. So unit vector, you can rewrite it if you can't see it properly. It's 1 over the magnitude minus 15 divided by 8. I hope you can see the value of the unit vector. So it is minus 15, 8, and then 1 over 17. So that's the answer to the problem for part A. We'll now proceed to the second part of the problem. So to the next question, which is 4b. Give me some time, be patient for me to erase that. So question 4b deals with vectors again. The whole question is on vectors. So 4b, you have given that 2a minus 5 is equal, not is equal, we have the plus 4b minus 12 and then 3 is equal to 4 column vector b minus a, and the y component is a to b, right? So we have 2a minus 5, which is equal to 4b minus 12, 3, and then we have 4 multiplied by the vector b minus a and a plus 2b. What we can do for this problem, we are basically adding the two vectors. So quite simple. When we add the two vectors on the left hand side, we are basically adding the x component, and it has to be equal to the x component here. The same is true for if I add the y component, which is there. It has to be equal to 4 multiplied by the y component. So let's split that and see how to work it. It's a simple question. So 2a for the x component plus 4b minus 12 is equal to 4 multiplied by b is 4b, 4 multiplied by a is 4a. The 4b on each side of the equation cancel out, and I'm left with 2a minus 12, which is equal to minus 4a. If we group the like terms, we have 2a and minus 4a. The minus 4a can be set on the left-hand side of the equation. You have 6a. The minus 12 is set on the right-hand side of the equation, which is 12. So simple algebra, simple maths, 12 divided by 6, which is 2. So that's the answer for A. So A is equal to 2. Let us now see how do we find the value of B. Now, you have for the y component, I'm just going to draw a straight line so that you can see the working, minus 5 plus 3, minus 5 plus 3 is equal to 4 multiplied by the y component, 4a, plus 4 multiplied by 2b, which is 8b. Okay, minus 5 plus 3 is minus 2. For the value of a, which is 2, plus 8b. So let us simplify. Minus 2 is equal to 4 times 2, which is 8, plus 8b. Now, if we simplify further, you would have 8b, which is equal to 10. Okay, so basically 8b is equal to minus 10, don't forget, because minus 2 minus 8 is minus 10. b is equal to minus 10 divided by 8. b is equal to minus 5 over 4. you can also write your answer as a mixed number, which is -1 and 1/4. So both of these, they are acceptable answers. So B is equal to -5/4 or B is equal to -1 and 1/4. So it's a simple question. Question 4 is based on vectors. The first one is unit vector, and the second one is basically addition of vectors and equal vectors. So the first concept is addition of vectors, and the second concept is equating the column on the left hand side with the column on the right hand side, so it's equal vectors. I hope you have a better grasp of the problem, and remember, vectors, they are very important when you are dealing with constant velocity problems as well, which is one of the challenging topics in maths. Okay, so we will now proceed to question number 5, and just bear with me when I erase the solution. Right, so let's see question number 5, straightforward, not difficult. Question number 5 is based on binomial theorem. So the first three terms in ascending powers of x in the expansion of 1 plus x over 12, 1 plus x over 6 to the power of 12, multiplied by 2 minus 3x to the power of 3, can be written in the form of 8 plus px plus qx squared, where p and q are constants. Find the values of p and q. This is binomial theorem. You need to recall your formula. Now remember, the more you practice, the lesser you rely on the second page of your question paper, which is about the list of formula. I'm going to write the formula for binomial theorem, and we are going to use that in this problem. Now it's 8 marks and it's a bit lengthy. We'll do it step by step and ensure that you understand it. So remember, for binomial theorem, when I have a plus b to the power of n is a positive integer for maths, so you have a to the power of n plus nc1 a to the power of n minus 1 plus nc2, I missed the b here, just writing too quickly, so b to the power of 1 plus nc2 a to the power of n minus 2 plus p squared plus dot 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 till you reach the last term, which is b to the power of n. So don't forget, a to the power of n plus nc1 a to the power of n minus 1, b to the power of 1, plus nc2 a to the power of n minus 2, b squared plus b to the power of n. So that's the formula for binomial theorem. Now we are given the product of two binomials. Let us expand one by one. So we will expand the first binomial, the second binomial, then we do the product. So I'm going to change color so that we can keep track of what we are doing. The first expansion is, I'm using my a device to read the question because I can't see the question as you are seeing it. So it's 1, but remember, this is not allowed in the exam because I'm also using my mobile for scientific calculator. And you need to have your own scientific calculator, physical one. So it's 1 plus x to the 6 to the power of 12. So that's the first binomial expansion. So let us expand. It's 1 to the power of 12 plus 12c1, 1 to the power of 12 minus 1, which is 11, x over 6 to the power of 1, plus 12c2, 1 to the power of 10, and then we have x over 6 to the squared. We are going to stop here because the question says the product can be written in the form of 8 plus px plus qx squared. So we only need till x squared. So let's check 1 to the power of 12 plus 12c1, 1 to the power of 11, x over 6 to the power of 1, plus 12c2, 1 to the power of 10, and then we have x over 6 to the power of 2. So 1 plus x over 6 to the power of 12 is equal to 1 to the power of anything is 1, plus 12c1 is just 12. 12 divided by 6, which is 2. So the second term is 2x. Plus 12c2 multiplied by 1 to the power of 10 is 1. 1 over 6 to the squared is basically 1 over 36. The x is just the term. We have 1 over 6. The coefficient of x is 1. If you use your calculator, you will be getting 11 plus 6 over x squared. It continues, but we will stop here. So that's the expansion of 1 plus 6 to the power of 12, which is equal to 1 plus 2x plus 11 over 6x squared. Let us now proceed to the second expansion, which is 2 minus 3x to the power of 3. Straightforward, but be careful with the sign. So when we expand that, the first term is 2 to the power of 3. Now, be careful. When there is a minus sign in between the two terms, the sign will alternate. So you will start with a plus here, and the second one will be minus. In this way, we avoid putting minus in brackets, which can confuse you. So remember, when we have a minus here, we start with plus, and the sign alternate. You will have plus, minus, plus, minus, plus, minus. So 2 to the cube, 3c1, and we have 2 to the squared, 3x to the power of 1. I'm not putting the minus here, because as I said, it's already taken care by alternating the sign. Okay? Plus 3c2 now, we alternate the sign, plus, minus, plus 3c2, 2 to the power of 1, and then we have 3x to the squared, and it continues, we stop there. So 2 minus 3x to the cube would be equal to 2 to the power of 3, which is 8. 3c1 is 3. 3 times 4, which is 12. 12 times 3 is 36. Minus 36x plus 3c2, which is 3. And 3 times 2, which is 6. 6 times 9 is 54x squared. So that's the second expansion. I'm just going to put an arrow here and just box it because we will need these results. Right, take a look. 1 plus x over 6 to the power of 12 is 1 plus 2x plus 11 over 6x squared. 2 minus 3x to the cube is 8 minus 36x plus 54x squared. That's the first part of the problem. Remember, we shall now deal with the product of these binomial expansion. So I'm going to erase the board, the glass board, so that we can do the binomial expansion when they are being multiplied now. So you can just note down these two expressions when you're doing the question at the same time with me. It's a lengthy one, so we need to erase so that we have space to do the calculation. Okay, guys, let's come back. Now the last stage, we need to do the product of 1 plus x over 6 to the power of 12 multiplied by 2 minus 3x to the cube. And that's equal, I'm going to change line so that we have space to work it out. It's equal to, for 1 plus x over 6 to the power of 12, it was 1 plus 2x plus 11 over 6x squared plus dot dot dot. That's for the first part. For 2 minus 3x to the cube, we got 8. The sign was alternating because of the minus sign in between the two terms. 8 minus 36x plus 54x squared plus dot dot dot. Move aside for you to see the working. Now, let's continue. What we need to do, we need to expand. But we need to expand intelligently. Why should we expand intelligently? Because at the same time, we group the like terms, x squared, and constant term. So we'll expand by taking first the constant term, then collect the x together, then collect the x squared, because it saves times in the exam and you don't get confused when you're simplifying the whole binomial expansion. Now, equal 1 times 8 is 8, and that's the only constant term which we can see. Now we need to look for the term in x. So we have 1 times 8, which is 8. I can draw the first arrow, but I will not draw for the others, otherwise it will be too confusing. We need to look for coefficients of x. 1 times minus 36, so I'm going to put in bracket. So minus 36x, so that's minus 36. Plus, do we have more x for the 1? No, because 1 times 54x squared is just x squared. But we have 2x times 8, which is 16x. So 16. If I continue with the 2x, I will get cube. So we stop here. We try 11 over 6 to the squared times 8. This is again x squared. So that's the only term for x. Plus, let's do the same for x squared. 1 times 54 is 54x squared. I'll just put the 54 here. 2x times 8 is already taken. 2x times 36x. Remember there is a minus here. So 2x times 36x is minus 72x squared, which is minus 72 here. Minus 72. Now, if I continue with the 2x, I will have x cubed, which is not interested. We are not interested with that. We are stopping till x squared. 11 over 6x squared times 8 is plus 88 over 6x squared. We stop here because we are not interested with the term in x cubed. Let's simplify. 8 minus 36 plus 16x is basically minus 20x. 54 minus 72 plus 88 over 6. So if you simplify that, you will get a minus 10 over 3x cubed plus dot dot dot. So I repeat, 54 minus 72 plus 88 over 6 would generate minus 10 over 3x cubed. We need to compare that with the expression which they have given in the question. 8, which we already got, very good, plus px, and then we have plus qx squared. Sorry, it's not x cubed. That's just writing too quickly. So let me write the x squared properly. So x squared because of x squared, which is here. So plus qx squared. So let's compare. We need to find the values of p and of q. So p would be basically minus 10, minus 20. And q would be, if I equate the q, so q would be minus 10 over 3. So these are the answers to the solution. So basically we have p is equal to minus 20, and then we have q is equal to minus 10 over 3. So as I said, we are doing the question live. So any problem which you have, just type your question and we will try to answer your problem. So this question is binomial theorem. It's worth, the number of marks is 8, and it's a lot of step in between, but of course when you get the answer by the end, you feel happy about it. We shall now proceed to question number 6. You can also read the question in the meantime while I'm erasing my solutions on the gloss board. The question is appearing. You read it, think about it. What are the steps involved? How do we generate the solution? Which chapter and concepts are related in that? So let's start. Question number 6 is, when you look, when we see polynomial, so when we see the polynomial px, the chapter which comes to your mind should be Riemannian factor theorem, right? In additional maths. So the polynomial px is equal to 6x cubed plus ax squared plus 6x plus b, where a and b are integers, is exactly divisible by 2x minus 1. When we see divisible, it means it is exactly divisible. And when it is exactly divisible, the theory which comes to your mind should be factor theorem. When px, the same polynomial, is divided by x minus 2, divided by x minus 2, you have a remainder of 120. Now, remainder theorem comes into play. So this question, as I said, is based on remainder and factor theorem. As simple as that, nothing complicated. Now, the polynomial px, so px, which is equal to 6x cubed plus ax squared plus 6x plus b, where a and b are integers, is divisible by 2x minus 1. If it is divisible by 2x minus 1, 2x minus 1 is equal to 0, x is equal to half. It means that when I substitute the half here, I should get 0. So p of half is equal to 0. Why? Because it's from factor theorem. Why it's factor theorem? Because it is exactly divisible. I'm just writing some notes for you to be able to understand why we are doing this step. Now, let's generate the equation for p of half. P of half means I replace all the x by half in the above polynomial. So that is 6 half to the cube plus a half to the squared plus 6 times half plus b, which is equal to 0, because it's exactly divisible. 1 over 8 to the cube, 1 over 2 to the cube is 6 over 8, as simple as that. And 6 over 8 is just 3/4. So let's simplify it. When it's very simple, we can just simplify. Plus 1 over 2 to the square is 1/4, which is a over 4. Plus 6 divided by 2, which is 3. Plus b is equal to 0. So 3/4 plus a over 4 plus 3 plus b is equal to 0. Now we have 4 here. We can just multiply each term by 4 and simplify the equation. This is a simple equation. I believe you should be able to simplify it just by looking at it and manipulating the LCM, that is multiplying by 4 in your head. That would generate a plus 4b, which is equal to minus 15. So a plus 4b is equal to minus 15 is technically the first equation which we are generating. So I will label it as equation 1. So that's equation 1, a plus 4b minus 15. Let us now deal with the second part of the problem. Now we have a, b, two unknowns, which means what do we need? We need another equation. So two unknowns, we need two equations, and the idea is to solve them simultaneously. Now, the same expression with the same polynomial, when it is divided by x minus 2, the remainder is 120, right? So which means that p of 2 is equal to 120 as specified in the question. Now, remember that the polynomial is a cubic polynomial, 6x cubed plus ax squared plus 6x plus b. Let us now replace the 2 in the x. We are substituting technically. So p of 2, substituting the 2, we have 6 times 2 to the cube plus a times 2 to the squared plus 6 times half. Sorry, it's 2, it's not half, plus 6 times 2 plus b, so I'm substituting the 2, so 2 to the cube plus 2 to the squared plus 6 times 2 plus b, this is equal to 120. Okay, now let us simplify. 2 to the power of 3 is 8, 8 times 6 is 48, plus 2 to the squared is 4, 4 times a is 4a, plus 12b plus b is equal to 120. So if we simplify this equation, so 48 plus 4a plus 12b plus b is equal to 120, we will have 4a plus b is equal to 60, and that's the second equation. That's equation number 2. So I repeat, 4a plus b is equal to 60 is the second equation. Now we have one equation which is there. We have a second equation which is here. The next step is to solve them simultaneously, which is quite straightforward. So solving 4a plus b is equal to 60 and a plus 4b is equal to minus 15. The strategy is, I would say, let us multiply the second equation by 4. So if we take the second equation, we multiply by 4, I would have 16a plus 4b is equal to 240. And I will call this equation number 3. So if we take 3, we subtract 1. So let me write equation 1 underneath so that you can see the working. So equation 1 is a plus 4b is equal to minus 15. That's equation number 1. Okay. Now, if we simplify it, we shall have, let's say we say 3 subtract 1. 16a minus a is 15a. The 4b cancel out. 240 subtract minus 15, that's 255. So a is 255 divided by 15, so this is 17. So the first part, the value of a, we got it. So 15a is equal to 255, a is equal to 17. Now we can substitute, once we get the value of a, we can substitute in any equation and you will get the value of b. So I suggest we substitute in equation 2 because we don't have any coefficient with b. It's a simple coefficient which is 1, more simpler. So from 2 we have 4a plus b is equal to 60. 4 is 17. 4 times 17 plus b is equal to 60. So straightforward. 4 times 17, just let me write the 4 nicely for you. 4 times 17 is 68 plus b is equal to 60. So b is equal to 60 minus 68, which is minus 8. So the answer for b is minus 8. So we got the two values, a is equal to 17 and b is equal to minus 8. I'll just let you contemplate the solution for a few seconds. Remember, it's based on the remainder and factor theorem. You generate two simultaneous equations and you get the two values. So a is equal to 17 and b is equal to minus 8. Okay, so we shall now proceed to part B of the problem. The question will appear, you read the question, and I will be erasing everything except the px, which we will need. Okay, now question number 6b. Before we continue, let us plug the values of a and b, otherwise we will be confused and it will be difficult to solve the problem. So px is equal to 6x cubed. For the value of a, it was 17x squared plus 6x, and for the value of b, it was minus 8. So let's double check. 6x cubed plus 17x squared plus 6x minus 8. Second part of the problem, Hence, write down the remainder when px is divided by x. Write down means straightforward, no calculation. When it is divided by x, it means it is divided by x minus 0. So we just replace 0 here. The 6x cubed would cancel out, the 7x squared would cancel out, the 6x would cancel out, and I'm left with minus 8. So that's the solution for C. I repeat, for the solution for C, it says x is the polynomial px is divided by x, which means that it is divided by x minus 0. We just substitute 0 in the polynomial. Now, for part C, we'll now proceed to part C, to the next problem. So, part C, the same question deals with px. So, find the value of p dash dash. So, the same question, part C. Find the value of p dash dash of 0. So, read the question, find the value of p dash dash of 0. So, p dash dash means what? It means second derivative. P dash dash means second derivative. So, we need to differentiate px twice. So, let's find the first derivative, p dash of x, which is equal to first derivative is 3 times 6, which is 18x squared. Okay? Plus, we have the 17x, so 3 times 6, which is 18x squared, 2 times 17, I'm working from here. So px is 6x cubed, first derivative is 18x squared, plus 2 times 17, which is 34x. Derivative of 6x, we differentiate 6x with respect to x, we get 6. Let's find the second derivative, p dash dash of x. So 18 times 2, which is 36x. Good. And then differentiation of 34x is 34. Differentiation of 6 is 0. We need to find the value of p dash dash of 0. We just substitute the 0 in the above expression for the second derivative. So we have p dash dash of 0, which is 34. So that's the answer to the problem. So p dash dash of 0, which is 34. 36 times 0 is 0. 0 plus 34 is 34. So that's the answer to question number 6, A, B, and C. It's quite an interesting question. First part, find the values of A and B. Second part, find the remainder when it is divided by x. And the last part is a bit of differentiation with it. So it's a multi-stage question, checking your executive functioning in the exam. We'll take 5 minutes pause, and please stay with us and see you in 5 minutes.
Bonjour, me présente moi-même. Moi, c'est Bhavna Anthony, professeur en biologie. L'examen est tout prêt. Mes élèves de haut et A-level à l'apprendre.mu prépare une série de past paper sessions qui peut faire en live sur Facebook. Me propose de rejoindre, faire vite, pas tarder, enregistrer sur alapprendre.mu. À bientôt!
Welcome back, fellow students. We will now proceed to question number 7. So let's see how question number 7 is. How do we deal with question number 7? Okay, so a quick reading. You will see that in each question that you are seeing, what happens is that you always have some of the keywords underlined. This is to grab your attention and also help you to generate the solution by recalling the concepts which are involved in the problem. Question number 7, if you have done few past papers, these are new styles of questions which Cambridge is incorporating in the paper. Doing LCM at the first stage, and then the second part is integration. For A-level, this is called partial fraction, but for AdMaths, we'll just treat it simply and deal with that. So 7a, show that 2 divided by 2x plus 3 minus 1 over x minus 1 will do the solution on the board. Divide by 1 divided by x minus 1 to the squared. So how do we simplify that and show that it is equal to 8 minus 3x divided by x minus 1 to the squared plus 2x plus 3? Let us do it together and we'll see how to proceed with that. The first step is look at the denominator of each fraction. 2x plus 3, x minus 1 to the squared. So clearly you observe that the LCM, I'll write it on top, the LCM is 2x plus 3 times x minus 1 to the squared. That's the first step, is to check what is the LCM for the problem. Now, having said that, it means everything should be in a common denominator. So the LCM is 2x plus 3 times x minus 1 to the squared. Because x minus 1 to the squared has the highest power as compared to x minus 1. Now, how do we generate term by term? Basically, we have 2x plus 3 times x minus 1 divided by 2x plus 3. The 2x plus 3 cancel out. You're left with x minus 1 to the squared. So x minus 1 to the squared times 2 is 2 into x minus 1 to the squared. I repeat, 2x plus 3 into x minus 1 to the squared divided by the denominator. The 2x plus 3 disappear. You're left with x minus 1 to the squared. Then you multiply by 2, which is 2 into 2x minus 1 to the squared. The same process will be applied for the remaining two fractions. 2x plus 3 into x minus 1 to the squared divided by x minus 1 times 1. That would give us 2x plus 3 multiplied by x minus 1 plus 2x plus 3 into x minus 1 to the squared divided by x minus 1 to the squared. The x minus 1 cancel out, and I'm left with 2x plus 3. The next step is to simplify the numerator, because look at this numerator. It's not nice at all. We have to simplify it to be able to show the required expression. So 2x plus 3 times x minus 1 to the squared. Let us expand the first one, which is trivial for an advanced student. This is basically binomial, which is perfect squared, a squared minus twice ab plus b squared. I'm just writing it here as a recall, because that should be straightforward for you to expand. So 2x squared minus 2x plus 1 minus, I'll put it in bracket because of the minus in front, 2x times x is 2x squared, 2x times 1 is minus 2x, 3 times x is 3x, so if we add them, we'll get plus x. 3 times minus 1 is minus 3, plus 2x plus 3. Now, we need to remove all the brackets, so we need to expand basically. We've been doing that right from the second step. So 2x squared minus 4x plus 1 minus 2x squared minus x plus 3 plus 2x plus 3 divided by 2x plus 3 times x minus 1 to the squared. We can just check the solution again. 2x squared minus 4x squared. You see, I missed the 2 here, so it's good that we check again. Plus 2 minus 2x squared minus x plus 3 plus 2x plus 3. Remember, we are doing it live calculation, so we should always recheck to ensure that we are doing it properly. The same situation as you are in the exam, I'm in the same situation like you now. I'm just solving the question live. We check each step together. So let's see what happens. You have the 2x squared, which cancels out. Okay? Minus 4x minus x is minus 5x. Minus 5x plus 2x, I'll just circle the like terms. Minus 4x minus 5x. Minus 4x minus x is minus 5x. Plus 2x, which is minus 3x. So from here, I have minus 3x. Now, 2 plus 3 is 5. 5 plus 3 is 8. Let me write it properly. So which is 8 here. Divide by the denominator. So that's equal to 2x plus 3 times x minus 1 to the squared. So 8 minus 3x divided by 2x plus 3 times x minus 1 to the squared. Boom, that's the required expression that we are asked to show. Just erase that a little bit and put it properly. So we've been asked to show that this whole simplification of the fraction is equal to 8 minus 3x divided by 2x plus 3 times x minus 1 to the squared. So the first step, the first question, done. So I hope you've been able to understand that this is basically an extension of manipulation of fraction in Form 2. Okay, so we'll now proceed to part B of the same question. I advise you to read the question in the meantime. Try to think about how we can solve this question, and I will come back to you in a few seconds. So let's see part B. Find the integral of 8 minus 3x divided by x minus 1 to the squared times x 2x plus 3. The lower limit is a, the upper limit is, the lower limit is 2, sorry, and the upper limit is a. You're integrating with respect to dx. A is greater than 2. You need to show that your answers can be expressed in the form of c plus ln d, where c and d, they are functions of a. Be careful, c and d, they are functions of a. From the first part of the problem, we've shown that 2 over 2x plus 3 minus 1 over x minus 1 plus 1 over x minus 1 to the squared is equal to 8 minus 3x divided by 2x plus 3 times x minus 1 to the squared. So we've shown that basically that it's equal to 8 minus 3x divided by 2x plus 3 times x minus 1 to the squared. The question is telling us to integrate this. Integrate with respect to dx. I'm just going to erase everything afterwards and to start it properly. I'm just giving you an insight now, which means that this is quite complicated to integrate. What we shall do, because they are equal, we are going to integrate the left-hand side. Those two fractions are equal. I'm going to integrate the left-hand side. That's part B. Rather than integrating something which is complex, I erase that part. I just integrate its equal fractions. We are integrating with respect to dx. When we integrate with respect to dx, the limits, they are from 2 to a. We shall now proceed with the integration. Now, integral of 2 divided by 2x plus 3. Quite straightforward. When I differentiate the denominator, when I differentiate 2x plus 3, I get the numerator. I get 2. So differentiation of 2x is 2. Differentiation of 3 is 0. So what happens when I differentiate the denominator and I get the numerator? It will be ln modulus of 2x plus 3 minus differentiate the denominator x minus 1, I get 1. So ln modulus of x minus 1. Careful here, when I'm integrating 1 over x minus 1, it's basically reverse chain rule for linear expression. So I'm just going to send everything in the numerator, which is x minus 1 to the power of minus 2. If we integrate x minus 1 to the power of minus 2, we add 1 with the power, so x minus 1, minus 2 plus 1 is minus 1. I divide by the new power, which is minus 1, and I multiply by the coefficient of x, which is 1. Don't forget, this is reverse of chain rule, and the limits, they are, the lower limit is 2 and the upper limit is a. Let me verify quickly in the question. Yes, it is correct, 2 and a. So we have ln of 2x plus 3 minus ln of x minus 1 plus x minus 1 to the power of minus 1 divided by minus 1. Let us simplify this line before we continue further. Ln of 2x plus 3 minus ln of x minus 1. So basically what's happening? Ln of a minus ln of b, laws of logarithm, we have ln of 2x plus 3 divided by x minus 1 modulus. Why do we put modulus? Because ln cannot be negative. Subtract, if I rearrange this term, it would be 1 divided by x minus 1, and the upper limit is a and the lower limit is 2. So here, remember, I'm just using ln of A minus ln of B is ln of A over B, minus rearranging the second term, which is 1 divided by x minus 1 to the squared. Let us now continue. The next step is to replace the upper limit and the lower limit. I'll give you some time to check the two steps, few seconds, and then we'll continue. All right, I think that's enough. So let's replace the upper limit. We have ln of x replaced by a. We are basically substituting ln of 2a plus 3 divided by a minus 1. We are substituting the a minus 1 divided by a minus 1. This is the upper limit replaced. Substituting the lower limit now, minus bracketed. The 2 being substituted would be ln. 2 times 2 is 4. 4 plus 3 is 7. 2 minus 1 is basically 1. So 7 over 1 is ln of 7. Minus. Let me substitute, well, in the second term. So 1 divided by 2 minus 1. 2 minus 1 is 1. 1 over 1 is 1. So that's basically ln of 7 minus 1. Let us simplify. Ln of modulus of 2a plus 3 divided by a minus 1 minus 1 divided by a minus 1 minus ln of 7 plus 1. Now, the next step of the problem is we say that it should be in the form of c plus ln of d, right? So we have to continue simplifying. So let's group the ln together. I have ln of this whole term minus ln of 7. Ln of a minus ln of b is ln of a over b. So from this line, let me continue. It will be ln of 2a plus 3 over a minus 1. We are subtracting minus ln of 7. So the 7 should go in the denominator. I'll just create some space. So 7 into a minus 1. Here we have plus 1 minus the 1 divided by a minus 1. Okay, so let's continue. That would be ln of 2a plus 3 divided by 7 a minus 1 modulus. And if you simplify these two terms, quite straightforward, 1 minus 1 over a minus 1, that would be a minus 1 as LCM, because 1 is basically 1 over 1. So a minus 1, which is a minus 2. So the answer is here. So ln of 2a plus 3 divided by 7 into a minus 1 plus simplifying these two, combining it as a single fraction, would be a minus 2 divided by a minus 1. So I hope that I've enlightened you on this problem. It is a bit long. It involves lots of concepts of integration, especially log, definite integral, but it's worth going through the problem live with you because you understand the intricacies in the problem. So I'll just give you a few minutes to look at the solution, and then we'll proceed to the next question. Okay guys, we shall now proceed to question 8. As usual, read the question, ponder on the steps involved, and we'll tackle the problem together. Okay, guys, let's discuss question number 8. So we read it together and then we tackle the problem together as usual. A team of 6 people is to be chosen from 10 people. 2 of the people are sisters who must not be separated. So the sisters cannot be separated. Find the number of different teams that can be formed. When we talk about the number of different teams, what should come to your mind is permutation. So the whole question, I believe, is based on permutation and combination. But for the first part, they are saying different teams. So it is basically combination rather than permutation. So the number of different teams, I repeat, is combination. And number of ways, when we talk about password, etc., which is part B, which we will discuss later, that deals with permutation. So the number of different teams means the number of combinations that are possible. Now, we have 10 people. So part A, we have 10 people. And we are trying to build a team of 6 people. Right? We have 2 sisters which should not be separated. 2 sisters that cannot be separated. So the question is, find the number of different teams that can be formed. So first we have to take it step by step. If we don't include the sisters, let's say sisters not included. Sisters not included, basically the number of combinations that are possible, sisters not included, which means it's already 10 minus 2, which is 8. Out of 8 people, how many people should we choose? 6 people. So it is basically 8C6. 8C6, using your calculator, is 28. So this is the 2 sisters not included. Now, let's say we include the 2 sisters now. 2 sisters included. If the 2 sisters are included, which means they're already in the team of 6. So, if they're already in the team of 6, we are choosing from 8 people, because the 2 sisters are in the team, and from these 8 people, how many people should we choose? Only 4, because the 2 sisters are already included. So what happens? It 8C4. 8C4 should give you 70, and if you add it, the number of teams that can be formed is 98 as final answer. The nice thing about permutations and combination is that we don't have lots of formula to remember, but what we need to remember is basically the logic behind it. Number of teams is combination. Number of ways, for example, where you have restrictions on passwords, etc., on order, where order matters, then we deal with permutations. So that's the first part of the problem, which is based on combination. Let us now proceed to the second part, part B. I advise you to read the question in the meantime. Try it. Okay. Part B. So 8B, first part of the problem. A 6-character password. So the password is 6 character. Is to be chosen from the following characters. So we basically have 3 digits, which are 2, 4, and 8. We have letters X, Y, and Z. And then we have symbols, the 3 different symbols which you see in the question. No character may be used more than once. That's a restriction. So when there is restriction, remember it's permutation. No characters can be formed more than once in any password. Find the number of different passwords, basically find the number of permutations that may be chosen if there are no restrictions. Very easy. If you count the total number of digits, letters, and symbols, we have 3 digits, 3 letters, 3 symbols. So the total is 9. We need 6-character password, so 9P6 calculator, that should give you 60480 as answer. Simple problem. let us now deal with the second part, B second part. For B second part, it says the password starts with the 2 letters. Restriction again, password starts with 2 letters and ends with 2 digits. For this type of problem, what I like to do, I like to draw a simple diagram to illustrate what's happening. A diagram helps for permutation because it helps you to visualize the concepts. So when you visualize it, you visualize the situation, you understand better the problem. We are dealing with 6-character password, so 1, 2, 3, 4, 5, 6. Simple as it is. The question says 2 letters at the start. So letters, we have 2 letters. And then we need to finish with 2 digits. Digits. So we have 2 digits here. So 2 letters there. Okay, and then we have 2 digits. Before proceeding further, in how many ways can I choose the 2 letters? We have basically 3 letters in the problem which they have given us, X, Y, and Z. We need to choose 2. So it's basically 3P2. 2 digits, we have how many digits? 3 digits, 2, 4, and 8. In how many ways can we choose that? It's 3P2 again. Remember, these are fixed, so 3P2 and 3P2. Now, we've already used 1, 2, 1, 2, which is 4. We have been given with 9 possibilities at the start because we have 3 digits, 2, 4, and 8, letters, 3 letters, X, Y, and Z, and then we have these 3 symbols. All right? We've already used 1, 2, and 2, which is 4. So 9 minus 4, we are left with 5 to choose from. So these 2 places, which are left, how many ways can I fill that? It would be 5P2 because I have 2 places which are left and I need to choose it from 5 possibilities. So the final answer for the problem would be 3P2 multiplied by 5P2 multiplied by 3P2. That should give us, use your calculator, 120 ways to solve this problem. So 120 permutations. So that's a nice question. So as I said, number of teams is combination. Restriction usually deals with permutations, number of ways. So I hope you had a glimpse of the problem and we can move to the next problem after a few minutes, 5 minutes break, and then we'll tackle the remaining problems. See you guys. So you can think about other stuff as well. So question number 9, if you want to deal with question number 9, let's proceed to question number 9. And we'll see what happens. So I'll erase the solution in the meantime. Okay, let's just look at question number 9. Question number 9 is related to the normal to the curve y is equal to, so I'll just write 9 here. Let's read the question together. The normal to the curve y is equal to ln of 3x squared plus 2 divided by x plus 1 at the point A on the curve where x is equal to 0 meets the x-axis at the point B. The point C has coordinates 0, 3l and 2. find the gradient of the line BC in terms of 2. So you're given the equation of the curve. There is a normal which is at the point A, and that normal meets the point B on the x-axis. So the first step is we need to find the y-coordinate of the point A. So the x-coordinate is given, we need to find the y-coordinate. So let us deal with this problem and see how do we solve that. So question number 9. Y is equal to ln of 3x squared plus 2 divided by x plus 1. Y is equal to ln of 3x squared plus 2 divided by x plus 1. Okay, so when part A, when x is equal to 0, you have y which is equal to, if we substitute 0 here, we have 0 to the square times 3, which is 0. 0 plus ln 2 is ln 2. Divided by 0 plus 1, which is 1. So we have y is equal to ln 2. So the point is technically a0 ln 2. The point is technically a0 ln 2. Now the next step is we need to differentiate. Why we need to differentiate? Because if we want to find equation of normal, we should find equation of tangent, or we should find the gradient of the tangent, and the reciprocal of the gradient of the tangent will give us the gradient of the normal. So y is equal to ln of 3x squared plus 2 divided by x plus 1. Let us find the gradient of the tangent by differentiating. This is the only way we can do that. So dy by dx, remember that's quotient rule. So quotient rule, you will have u on top, and this is taken as v. So v, which is x plus 1, du by dx, remember you are differentiating ln of 3x squared plus 2. Just going to erase that and put it here. So v, which is x plus 1, du by dx, you differentiate ln, you will have 3x plus 2 in the denominator. Differentiate the denominator, you have differentiation of 3x squared is 6x. So we have 6x divided by 3x squared plus 2. Minus u, which is ln of 3x squared plus 2, differentiation of dv by dx, which is 1. So I'm not going to write the 1 because it's multiplied by 1. Divide by v squared, which is x plus 1. The point A is 0 ln 2, and the normal is at this point. Let's find the gradient of the tangent. dy by dx when x is equal to 0, because we have 0 here, 0 ln 2. If I replace 0 here, I have 1. 0 in the fraction, that disappears. I replace 0 in the second term, I have minus ln 2. 0 in the denominator, it's 0 plus 1 to the squared, which is minus ln 2. Let me rewrite it nicely so that you can see it. So dy by dx when x is equal to 0 is minus ln 2. Remember, this is gradient of tangent. Now, if we want to find the gradient of the normal, so gradient of the normal would be inverting the gradient of the tangent, which is ln 2, and then changing the sign, which is plus 1. So the gradient of the normal is 1 over ln 2. I repeat, gradient of the normal is minus 1 over gradient of tangent. So that should be gradient of normal, which is negative reciprocal of the gradient of the tangent. So it's 1 over ln 2. So we got the gradient of the normal now. The next step is to find the equation of the normal, which is straightforward. So just take a look at the solution for a few minutes. I'm going to erase that part and then continue. So the gradient of the normal is achieved, which is 1 over ln 2. Okay guys, so we'll erase that and continue the problem. right? So just to recap, the gradient of the normal, m of normal, was 1 over ln2, and the normal was at the point A, which was 0 ln2. So equation of normal is y is equal to mx plus c. The gradient is 1 over ln2 times x, and the c is very straightforward. If you see 0 ln2, that should be the c, which is the y-intercept. So you would have ln2 here as well. So this is the equation of the normal. I hope it's quite straightforward. Now, let's revert back to the problem. The normal is meeting the x-axis at the point B. So on x-axis, what happens? On x-axis, we have y is equal to 0. When y is equal to 0, we have 1 over 2x. I'm using this equation. 1 over 2x plus ln2, which is equal to 0. So the x here, we can just rewrite it for simplicity as x divided by ln2. So x over ln2, send that on the right hand side, is minus ln2. Cross multiplication, ln2 times ln2 is minus ln2 to the squared. That's the x coordinate of the point B. So therefore, the final step, point B is minus ln2 to the squared, bracketed, and 0. So that's the coordinate of B, which is minus ln2 to the squared and 0. So coordinates B minus ln2 to the squared, comma 0. We've already got the coordinate of B. The last step is to find the gradient. We'll just go for a pause for 5 minutes, look at the solution. It's a long problem. Check it again and see you within 2 minutes.
Bonjour, me présente moi-même. Moi, c'est Bhavna Karantoni, professeur en biologie. L'examen est tout prêt. Zut, mes élèves de haut et level, Alapprendre.mu prépare une série de past paper sessions qui peut faire en live sur Facebook. Je propose de rejoindre, faire vite, pas tarder, enregistrer sur alapprendre.mu. À bientôt!
Welcome back, guys. We just calculated the value of x, and that gave us b, which is minus ln2 to the squared 0. Now the last step of the problem is to find the gradient of bc in terms of ln2. Now c is 0, 3 ln2, so the gradient of bc, gradient is represented by small letter b, gradient of bc would be y2 minus y1 divided by x2 minus x1. Remember, gradient is y2 minus y1 divided by x2 minus x1. That's quite straightforward. So if you use that for these 2 points, you will have 3 ln2 divided by ln2 to the squared. The ln2 cross out, you would have ln2 in the denominator. So the gradient is therefore 3 over ln2. That's the final answer, and it is in terms of ln2. So gradient of BC is 3 over ln2. So few seconds to take a look at the problem. That's the last step. It's quite a long question. There are different conceptual understanding involved, concepts to remember, and if you look at the question, it's question number 9, so you expect to get quite complex questions when you're trying by the end of the paper. Let us now move to question number 10. While I'm erasing the board, you please analyze, read first, analyze, and break down question number 10 in pieces for you to be able to grasp the concepts involved. Okay, students. Question number 10a. Given the simultaneous equations log of x plus 2 log of y is equal to 1, x minus 3y squared is equal to 13, you're asked to show for the first part x squared minus 13x minus 30. Straightforward. When you see log, you know that laws of logarithm have to be into play. So we have lgx plus 2lgy is equal to 1. So lgx plus, the 2 goes on top, power law of logarithm, which is equal to lgy squared is equal to 1. 1 is technically lg10. Why? Because lg10 is 1, log of 10 to base 10 is 1. Product law of logarithm, so log of x plus log of y squared is log of xy squared, which is equal to lg of 10. One term on both sides involving log, so the log would disappear by the concept of anti-log. So you have xy squared, which is equal to 10. If I make y squared the subject of formula, I have y squared, which is equal to 10 over x. And I'm going to substitute that in the second equation. The second equation is x minus 3y squared, which is equal to 13. X minus 3 y squared is 10 over x, which is equal to 13. So that should involve x minus 30 over x. 3 times 10 is 30, is equal to 30. If I multiply each term by x and I rearrange, I should have x squared minus 30 is equal to 13x. Let us now rearrange. Therefore, x squared minus 13x minus 30 is equal to 0. Work is done. We've been able to show it. I like to write hence shown when I prove something. So x squared minus 13x minus 30 is equal to 0 is what you have been asked to prove or show. Simple step, laws of logarithm involve, subject of formula, substitution, and the work is done. This is pretty straightforward for 2 marks. We'll now proceed to the second part of the problem. You can start it in the meantime, the reading at least, and we'll continue with the working because it's related to part 1. Second part, solve the simultaneous equation, giving your answers in exact form. You're asked to solve the simultaneous equation, and you need to give your answer in exact form, which means they don't want decimal places, non-terminating decimal places. Technically speaking, there will be some exact square root, surd, and things like that. So solve this simultaneous equation. Well, we got x squared minus 13x minus 30 is equal to 0. That's a very simple quadratic to solve. Just by factorizing x minus 15, x plus 2 is equal to 0. We have x is equal to 15 or x is equal to minus 2. If you go back to the problem, you will see that the first equation was lgx plus 2lgy is equal to minus 1. So log is not defined for a negative value. So minus 2 is rejected because lgx is not defined. So the answer is x is equal to 15. Now we have the relationship y is equal to, so y squared is equal to 10 over x, which we have deduced from the first equation. Y squared is equal to 10 over x. We just need to substitute the x is equal to 15. Y squared is 10 over 15. And 10 over 15, simple maths, you divide by 5, that should be 2/3. Y squared is 2/3. So y is equal to plus or minus square root of 2/3. Remember, from the first equation, log of y is not defined for negative value. So I would say y is only the positive value, because Lg of y needs to be positive. Okay, remember, the y here needs to be positive. You can also rationalize this expression, this value if you want, but honestly speaking, when you reach that stage, you should be able to get the answer. That's the final answer. Y is equal to square root of 2 over 3, positive value, and x is equal to 15. Again, straightforward question, not complicated, for the 10th question in a paper. Let us now proceed to part B of the problem. Part B of the problem, solve the equation log of x to base a plus 3 log of a to base x is equal to 4, where a is a positive constant, giving x in terms of a. So let's go back to the board and tackle the problem. For part B, we are asked to solve log of x to base a plus 3 log of a to base x is equal to 4. And a is a positive constant, a is greater than 4. Now, be careful that the base are not equal. The base are not the same. When the base are not the same, you already know that we need to use the concept of change of base. Very simple. Change of base tells you that the formula log of a to base b, if I change it to base of c, it would be log of a to base c divided by log of b to base c. Remember, that's the concept of change of base. We won't do the proof how it is like that. That's done when I usually teach the chapter. Here we are just solving past papers question to develop exam skills. I'm going to erase it now, so that we can understand the problem. So as I said, change of base formula. Now let's change the base to a. So the first one is already the same thing, log of x to base a plus 3. Let's change log of a to base x, we'll change it to base a. So it's log of a to base a divided by log of x to base a. I'm using this concept, log of a to base b, change of base to c, log of a to base c divided by log of b to base c. That's the concept of change of base. So here we are not changing the base, it's still log of x to base a. This one is log of a to base a divided by log of x to base a because we are using the formula for change of base. Let us now complete the equation, which is equal to 4. I'll erase the formula, assuming that this is trivial for you. Now, if you look at it, log of a to base a is 1. So we have log of x to base a plus 3. What is log of a to base a? 1 divided by log of x to base a, which is equal to 4. Sometimes when students look at this equation, they think that it's a bit difficult. It's not difficult. The log, they are the same. So what do? We can use substitution. Let y is equal to log of x to base a. It will simplify the equation and you will be able to see what's happening. Log of x to base a, which is y, plus 3 over y is equal to 4. I'm using this substitution. So if I multiply everything by y squared and rearrange, by y squared plus 3 is equal to 4y. And if we rearrange the last equation, we will have y squared minus 4y plus 3, which is equal to 0. Let us factorize y minus 1 times y minus 3, which is equal to 0. Y is equal to 1 or y is equal to 3. What is y? Y is defined by log of x to base a. Log of x to base a is 1. Log of x to base a is 3. So x is equal to a to the power of 1, which is a. X is equal to a to the power of 3, which is a cube. So these are the answers. X is equal to a and x is equal to a cube. So I'll move on the right hand side so that you can see what's happening. So log of x to base a is equal to 1, x is equal to a to the power of 1, log of x to base a is equal to 3, x is equal to a cubed. So question number 10 done. I hope you've enjoyed solving the problem with me. It's not a difficult problem. It's actually quite interesting and straightforward. Let us now proceed to question number 11. Question 11 is the last question in the paper. I know you're tired. We've been solving questions continuously, but bear with me. We'll tackle the last question and we will be done for today. All right. Question number 11. In this question, all lengths are in kilometers and the time in hours. When you see length in kilometers, time in hours, you know that in AdMaths, this has to be dealt with kinematics, right? So we are dealing with kinematics problems, and most specifically using calculus. You know that's one of the topics in AdMaths, and it's basically my favorite topic when we need to deal with calculus, kinematics, the applications, and sometimes constant velocity problems. A particle P moves in a straight line such that the displacement from a fixed point at time t is given by, so the displacement is s, which is equal to, we go to the board so that we can understand the problem. So s is equal to t plus 2 times t minus 5 to the square. Okay, so that's the expression, the equation for the displacement. So s is equal to t plus 2 times t minus 5 to the squared. And remember, time is always greater than 0. It's positive. Find the values of t for the first part for which the velocity is 0. Recap, you have s, v, a. Displacement, velocity, acceleration. When I go down, I differentiate with respect to t. So if I differentiate displacement, I get velocity. If I differentiate velocity, I get acceleration. When I move up, if I integrate with respect to time, if I integrate acceleration, I get velocity. And if I integrate velocity, I get displacement. The question says, you are given displacement, you need to find velocity. What you should do? Displacement, we need to find velocity, so we need to differentiate with respect to time because we are going downwards. So let us tackle the problem. That's a very nice equation for s. Product of two terms will be basically product rule, u, and that one is v. So if I differentiate ds by dt, I will be getting the velocity which is v. So ds by dt, product rule means v, t minus 5 to the squared, du by dx, which is 1, plus t plus 2. I keep the t plus 2 and I differentiate the v, so that's chain rule. The 2 goes in front, t minus 5, the power decreases by 1, and when we differentiate the inside, we have 1. It's chain rule. So v is equal to t minus 5 to the squared plus 2 times t plus 2 multiplied by t minus 5. Now, if you look at it, you see that t minus 5 is common. I can factorize the t minus 5 outside to get a nice expression. Open bracket. T minus 5 inside, because t minus 5 times t minus 5 brings me to the original term, which is t minus 5 to the squared, plus 2. I've already factorized the t minus 5, so that should be t minus 5 again. So let us simplify. V is technically t minus 5. Now, t plus 2t, if we expand the inside, 2 times t is 2t, 2t plus t is 3t. Minus 5 minus 10, so basically minus 5, so that should be plus 2. Sorry, there is a mistake, calculation mistake here, because that's already factorized, so it's plus 2. So it's good that we check each step so that we don't make any mistake. So basically, that would be 3t minus 5. 2 times 2 is 4. That would be minus 1. So we have v is equal to t minus 5 into 3t minus 1. Now, the velocity is equal to 0, as suggested in the question. So t is basically 5, or t is 1 over 3. So that's the answer. These are the 2 times when the velocity is 0. T is equal to 5 and t is equal to 1/3. Now, just a quick recap on this. When we factorize the t minus 5, basically we can also expand that just to see what kind of equation is that. So if you look at it, it's quadratic. Sometimes it is helpful to expand it, especially when they tell us to find the acceleration. So if we expand that, we will have v is equal to 3t squared minus t minus 15t gives me minus 16t. Minus 5 times minus 1 is plus 5. So if we expand it, the velocity t minus 5 into t minus 1 can also be equal to 3t squared minus 6t plus 5. So this is also possible. As I said, why do we expand it? If there is further calculation, it becomes very simple to manipulate. So t minus 5 into 3t minus 1 is the same as 3t squared minus 6t plus 5. Okay, guys? So I hope you've understood the problem. We are just using the concept of SVA. Let us now move to part B. While you read the question, I will be erasing my solution. Question number 11b. On the axis, draw the displacement graph for t is equal to 0, well, between t is equal to 0 and t is equal to 6, using the stating the coordinates of the points where the graph meets the coordinate axis. So basically, they are telling you, let's do the question on the board, they are telling you to sketch t plus 2 and t minus 5 to the squared, which is the equation for displacement. So that's the vertical axis, which is s, let's say in meters, well, kilometers in the question. We don't need to put the units, it's not arcs in the question, so just s. And then we have time, which is there. So we start with 0. Now, when t is equal to 0, let's do some calculation to help us. S is basically, let's replace here. When t is equal to 0, 0 plus 2 is 2. 0 minus 5 is minus 5. Minus 5 to the squared is 25. And 25 times 2 is 50. So when s is equal to 0, we have 50, which is there. Okay? Now, if you look at it, it's t to the squared and t. So it's a cubic curve. Now, the time is between 0 and 6. So when t is equal to 6, let's see what happens. You replace 6 plus 2 is 8, 6 minus 1 is 1, 1 to the squared is 1. So we are left with s is equal to 8. So it's a sketch. Let's say the 8 is somewhere here. That's the point 6, 8. And this one is the point 0, 50. Now, we have the times where v is equal to 0. So the times where v is equal to 0 is 1/3, which is somewhere here. And then we have t is equal to 5. Let's say 5 is there. So that point is 5, 0. And this one is 1/3, 0. Now, let's see what happens when t is equal to 1/3. So when t is equal to 1/3, and you replace in the same equation, 1/3 plus 2, and then 1/3 minus 5 to the squared. If I do that on my calculator, Just give me a few minutes. That would give us 50.8. So basically, 50.8 is a little bit up here. So that's the point 1/3 and 50.8. We got all the ingredients which are necessary. It's a cubic curve. So the shape of the curve is here to here. It touches there and it goes there. So that's the cubic curve which represents the displacement. S is equal to t plus 2, t minus 5 to the squared. We have all the points which are necessary. So this 1/3, 50.8 and 50, these are two turning points. Straightforward question based on the equation which you've got. Let us now proceed to part C, which is also about sketching. I advise you read the question and I will come back to you in a few seconds. For part C, on the axis below, draw the velocity time graph, again for the same time interval between 0 and 6, stating the coordinates where the points where the graph meets the axis. So let's remember that for this time, we have v which is equal to 3t minus 1. We got that, t minus 5. Don't forget that v is equal to 3t minus 1 and t minus 5. And we said it's also equal to 3t squared minus 16t plus 5. 3t squared minus 16t plus 5. Now, the coefficient of t squared is positive. 3 is positive. Remember, when you have a quadratic which is ax squared plus bx plus c, when a is positive, you have a minimum point. So a is equal to 3, which is positive. So the sketch of v needs to have a minimum point. Let's see what happens. Vertical axis v, horizontal axis is time. We have 0 here. When t is equal to 0, we can just replace. The 0 cancel out. The 0 cancel out. We have 5. So 5 is somewhere here. 0, 5. 0, 5. Let me rewrite it so that you can see it clearly. 0, 5. When t is equal to 6, so if you replace 6, you can replace in the top one as well, because it's easier to manipulate. So if you replace t is equal to 6, you will have 6 times 3, which is 18. 18 minus 1 is 17. 6 minus 5 is 1. So you would have v is equal to 17. So let's say 17 is somewhere here. It's just a sketch. We don't need to be that exact. We need to be accurate, but not exact. So we have 6 and 17. Now, of course, as I said, it's a minimum point. So technically speaking, the graph is like that. We don't need to say where is the minimum point. That's enough. But here, remember, it's 1/3. This is the time when v is equal to 0. And this one is 5, as we got in the first question. So 1/3 and 0, they are the times when the velocity is 0. I hope you understand the problem. It's not difficult. It's still about sketching. So 0, 5, 1/3, 5, and we have the point 6, 17. Let us now proceed to the next part of the problem, which is part D. So part D, write down an expression for the acceleration of p at time t. So again, we go back to the SVA. Part D, acceleration, so SVA. When you have velocity, you want acceleration, you need to differentiate. Don't forget that. Acceleration is dv by dt, and v was equal to 3t squared minus 16t plus 5. So acceleration is dv by dt. Differentiation of 3t squared is 6t. Differentiation of minus 16t is minus 16. So the acceleration is 6t minus 16. Very straightforward calculation if you have the equation for v. Not a difficult problem, and the answer to this question is 60 minus 16. The mark is only 1 mark, straightforward. We'll now move to the second part. So next question, the second part. Hence, on the axis below, draw the acceleration time graph for the interval t between 0 and 6, stating the coordinates of the points where the graph meets the coordinate axis. That's actually a nice question, a very simple one. Let's do the calculation, not the calculation, but using the equation, let's sketch it. So A was 60 minus 16. That's the equation. If you look at that, it's basically like y is equal to mx plus c, right? So y is equal to mx plus c. It's just a straight line because the x represents t. So that's a straight line. Not a big deal. So a t, that's 0. That's the time t, 6. T is equal to 6. When the time is 0, if I substitute 0 here, I have minus 16. So that's the point 0 minus 16. When t is equal to 6, 6 times 6 is 36. 36 minus 16, I replace in the equation for acceleration. So 36 minus 16 is basically 20. So we have 6, 20 here. So if I sketch the graph, it's a linear equation. How do we get this value? On the t-axis, the acceleration is 0. So a is equal to 60 minus 16. When t, so on the t-axis, acceleration is 0. On t-axis, acceleration is 0. Don't forget that. So the acceleration is 0. We have 60 minus 16. T is equal to 16 divided by 6. T is equal to 8 over 3. 8 over 3 is basically 2/3. So here, it's 8 over 3, or you can write it as 2/3. Why I'm writing this value? Because the question says, write down the points, show on the sketch the points where it crosses the axes. So we have 0 minus 16, 8 over 3, and 6, 20, which are the boundaries. So that's the sketch for the acceleration. Kinematics is quite an interesting topic because it deals with the applications of differential calculus, which is basically differentiation and integral calculus. And that's the beauty of doing these topics when everything is merged. And as you already know, kinematics is a topic in physics as well, where you understand the motion of particles of objects. We have now reached the last question. So before we proceed to say goodbye, I will just give you some tips on the problems. When you are dealing with exam questions, make sure that you know which topics are involved. Which topics are involved means you know the basic formula. If it's not on the list on the page 2, you know what variables are in the formula, when to use them, and how to deal with them. Second thing, read the instructions properly. Read the question properly, highlight the keywords so that you understand how to generate the solution based on these keywords. The last one, don't forget that non-exact numerical answers should be given to 3 significant figures, unless a different level of accuracy is specified in the question. And for angle in degrees, it's 1 decimal place. So good luck for your exam. But don't forget, we will be tackling paper 2 soon, and see you soon. Bye-bye and all the best.
Bonjour, me présente moi-même. Moi, c'est Bhavna Anthony, professeur en biologie. L'examen est tout prêt. Zut mes élèves de haut et level à l'apprendre.mu peut préparer une série de past paper sessions qui peut faire en live sur Facebook. Me propose de rejoindre, faire vite, pas tarder, enregistrer sur alapprendre.mu. À bientôt!
On your mark!